Hi, I'm Dr. Christopher Newman. I'm Professor of Space Law and Policy at the University of Northumbria in Newcastle in the United Kingdom. I'm also International Space Law Advisor for Cold Star Technologies. I listen to the Cold Star Project.
This show is for entertainment purposes only and is not what is termed professional advice. The Cold Star Project is proudly presented by the Operational Excellence Society. Cold Star Tech is a supporter of the OPEX Society, and Jason Kanigan is a member of its board of advisors. Talk with us at Cold Star Tech to find out what we can achieve together with your Lean Six Sigma or Operational Excellence programs. And check out opexsociety.org to learn more. So after Michelle Hanlon's appearance on the show, Rand Simberg reached out to me, probably because he's a member of the International Institute of Space Law, so he's interested in that topic. Rand is interested in a lot of things. He describes himself as a recovering aerospace engineer, having worked with Aerospace Corporation and with Rockwell International. After that, he's been an entrepreneur and consultant in space tech and business development, and also regulatory issues, especially regarding commercial and personal spaceflight. He was an adjunct scholar with the Competitive Enterprise Institute, and he's written a lot of pieces for magazines and papers, like Popular Mechanics and Washington Times and New Atlantis, and even Fox News. So I like that he was so well-rounded. He had a couple of really good things to talk about that we're going to get into that I have not heard other space experts discussing. And so once we broke into that, I was like, wow, let's get you on. So Rand, welcome. All right, Rand, you are the author of a book, a space industry book called Safe is Not an Option, about what's holding us back from innovation. I saw your stat in the description that about 4% of astronauts have died, and while we would wish it would be zero, I actually looked up the death rate of the US presidents, and it's about 17%. It's a lot easier to die in office, whether from natural causes or being shot, than being an astronaut. So tell me what made you want to write this book?
This is about a decade ago, and I was very concerned that NASA has been risk averse forever. Not forever, but since Challenger, let's say. And I kind of got used to that, but I was very concerned with the coming commercial vehicles that was going to bleed over into the commercial side. And to some degree, it sort of did with commercial crew, but it hasn't yet, at least, happened in terms of the people who are doing stuff purely privately. So I was trying to head that off at the pass, so to speak, but also just to get people, also to see if we could break NASA out of that mindset, or Congress, because it really held us, the insistence of commercial crew, where they came up with an arbitrary loss of crew number. I think it was 1 in 270 or something like that, or 1 in 320. I can't remember which. But it was both arbitrary and unverifiable. They will never know what the actual probability of dying, on a Crew Dragon or a Starliner is, because they won't even fly it enough,
right,
to know that. But it held us back for years. We could have been flying much sooner if they'd been willing to take more risk. And we could have not been sending Putin millions of dollars for as long as we did. And we didn't have to be dependent as long as we did. And one of the points I make is that our risk aversion in space is a testament to how unimportant it is. Right?
Okay.
If it was really important to get people to the moon, if it was really important to end our dependence on the Russians, it should have been, right? But it wasn't. If it was really important, they would have said, okay, we're going to take some risk. And the astronauts would have accepted that. They did in the 60s. Neil and Buzz, they thought they had maybe a 50% chance of getting back.
Okay, so who insists that safety be the priority then?
Congress. I mean, after the penultimate shuttle launch, not the last one, but the one before. I can't remember who. I think it was Shaka Fatah. Complimented Bolden, saying He was so happy that he was making safety the highest priority. Okay, which is stupid if you think about it. If safety is the highest priority, then actually accomplishing things is a lower priority.
Right. And I mean, that sounds straightforward. We are talking about people's lives here, but I will direct those who haven't really thought too much about it back to the test pilot period when jet engines were being brought out. And I'll come back to this, I guess. I mean, I could ask it now. Is secrecy a requirement? Do you think we should go back to that? Because I imagine with the test pilot program, that was all shrouded under secrecy and guys went to work and nobody knew what they were working on. So if they crashed and died, I wasn't there. So I don't know if it was a news story or not when a test pilot died.
Well, it was a news story, but it was just a news story.
Okay.
It wasn't something that we had national angst over.
Right,
Because, you know,
right.
test pilots were expected, that's what they did.
Yeah.
And in fact, you know, when they strapped those guys to the top of those rockets, you know, Mercury 7, that was the safest thing they'd ever done in their career.
Okay. Well, all right. So you bring up a point there. I've got this question written on my notes. We didn't get to talk too much about notes in between. So this is an interesting matchup. How do we avoid that emotional gut punch when astronauts die, right? When something explodes and we have fatalities.
Well, you have to make it clear to the public that this is a dangerous activity. That, you know, these are national heroes, and they're not national treasures, you know, too precious to be, you know, risked on something as hazardous as human spaceflight. You build a set aside a huge. They have one down at Florida. They have an astronaut memorial, right? But you could set aside, if we were serious, you would set aside a big plot of land like Arlington. And say, this is where the people who are going to go, who die opening up this frontier. Okay, if we were serious about it, that's the kind of thing we would do, and then people would accept it. But it was, I mean, part of it was Challenger was just like the worst possible flight for that to have happened, because it had the teacher aboard and all the school kids were watching, right? So it was just a very traumatic thing. And we've been told, oh, this space shuttle is safe. You know, it was just a shock that you know, the space shuttle could be destroyed in flight.
Right. I remember.
And NASA had been lying about it.
Yeah.
You know, they put forth this idea that it was much more reliable than it was. You know, Feynman pointed that out. Because I was working in the trenches at Rockwell and Downey, and we knew, you know, it wasn't 1 in 10,000, and we knew it wasn't 4 nines. You know, we had a fault tree of all the things, you know, that could give you a bad day with that thing. And you know, we expected an engine to blow up or something. You know, that was the most likely thing. Or what happened with Columbia. You know, we anticipated that. You know,
re-entry.
Might have an entry problem because you know, disrupt the integrity of the tiles. But Challenger was such. It was not on the fault trees. Nobody said we're going to have a joint open up and reclose, and while it's open, it's going to, you know, blowtorch the strut, you know, to the point where it weakens it, to the point where it separates, and the SRB comes and crushes the upper dome of the ET. You know, nobody anticipated that. You know, it wasn't on any fault tree. And if it had been, it was kind of like the Titanic, you know, or the Donner Party. It's not just, if just one thing had gone right, it would have lived, right? But it's like everything went wrong. If it had been pointing in a different direction, so it didn't cut the strut, you know, or if it had been just a little bit warmer that morning.
Okay. Yeah, so there is kind of a learning cycle here, and we have to expect that the absolute worst, I'm not laughing at it, but the conditions, right? It's almost ridiculous when you think about it, that all these check marks of negativity have to happen to get to the end result, right?
Yeah, I mean, it's a complex, tightly coupled system, and that can have very catastrophic failure modes.
Yeah, so we can't plan for some of this stuff, and big nations have casualties. This is something that I don't think. I mean, I think back to Lebanon and the Beirut bombing, and you know, in the 80s also, and there was a lot of upset about that. And yeah, for those people and their families, it really sucked. But probably the message at the time was that, you know, should have been, this is a big nation and big nations have casualties, and it's not fun, but we have to move on. So
here's another example I
yeah.
use from the book, you know, about the fact that space isn't important. From about 1948, I think 49, when they first started doing jets on carriers, through about the mid 1980s, when they finally got it figured out. They got their
Wow.
their rate. They got their rate down, accident rate down to that of the Air Force. Okay, so how many people do you think died in non-combat operations learning that?
I'm going to guess hundreds.
Thousands.
Wow.
Thousands of deck crew and pilots.
Yeah. Okay.
To learn
I
how
can see that. They're all out there like bowling pins.
Yeah. And you know, and their fires, and you know, just to learn how to fly jets off carriers. So that's the kind of thing you do when something's important.
Wow. I recently watched a talk with by a former F-14 pilot with Rear Admiral who has retired and gone on to he ran the Naval War College, one of them, and is now Nebraska, and he had flown thousands of flight hours, and it's interesting that never came up, right? He ended up commanding a nuclear aircraft carrier and had all these flight hours, and was a combat pilot for a very long time, probably longer than most of his commanding officers would have liked, you know, the guys up the chain, right? And interesting, and it's just kind of, yep, it's fine. I mean, the guy was flying F-4 Phantoms when he started out.
And
you know, you don't hear about crashing and burning
till the Hornet and the Tomcat that we really got the accident rate down. They finally figured out this is how you design a carrier aircraft.
And so thousands of people have died. I'm going to check these stats out, and it's hardly talked about, right? Or just kind of lumped into, well, this is what we have to go through to get to what we want.
And again, that's non-combat.
Right. Okay. So this may not have been somebody off the coast of Vietnam having just flown a strike mission and coming back. Okay. That's disturbing. It's really disturbing. So, okay. What agencies or requirements are slowing us down as far as innovation goes here with this problem, right? Of holding safety as too high of a value.
Well, I guess it's so far it's not the FAA, fortunately. But you know, because there's been a moratorium on them, we're in a learning period, so-called, since 2004 when we amended the Commercial Space Launch Act. You know, FAA on the space side, we're not talking about aviation, we're talking about space. FAA AST, the Office of Commercial Space Transportation, has never done mission assurance. Okay, they don't, when they launch a license to launch, they don't care if the satellite gets to orbit or not. That's not their, I mean, maybe they personally care, but it's not their job to worry about that. All they care about is that the rocket doesn't, you know, fall on somebody's head. You know, it doesn't hit, you know, damage an endangered species or a foreign national, or, you know, and uninvolved third parties in general. That's all they care about. And that's been the case also with not passenger, you know, space flight participants. We don't call them passengers,
Right,
because that implies a level of safety that simply is not there. So they're called in the law space flight participants. So up until, and so they had that moratorium in place because they didn't think at the time, we didn't believe at the time that we knew enough to be able to regulate this. And that moratorium has been extended several times, and it's expiring again in October. And there's kind of a fight right now to try to get it extended again. And there's been kind of a push to say, no, it's time to start regulating this thing. I disagree for two reasons. I think it's still the case that we don't know how to do it. And B, different people have different, you know, risk tolerances. You know, suppose somebody wants to skydive from space. He wants to go up, you know, 100 kilometers and jump. Okay, that's kind of a, you know, risky thing to do, right? So how much are you going to, is it probably the rocket ride up there is much safer than what he's planning to do. Right. And people, people climb Everest. And about, I think, 2% of the people who climb Everest die.
Right. Yeah.
So why should we insist on 3 nines or 4 nines for a space flight?
Okay.
And you're going to have, and you can, airlines cannot compete on safety. Right. You can compete on how good looking are the flight attendants, what kind of snacks do you provide, lots of stuff, but you can't, but everybody has the same expectation of getting off the airplane, safely at the end of their flight, no matter which airline it is, because that's the FAA insists on that. But that we're not at that stage with spaceflight. Some people, so there actually will be competition if Blue Origin wants to say, well, we're safer than Virgin Galactic because we have this abort system or whatever. They can do that, and people can make the choice. Say, yeah, this is a more exciting ride, but it's more dangerous. But that's my choice.
Yeah. So there is a commercial value to safety. You're saying,
Yeah, we're in the barnstorming era still.
Yeah. That if you're holding on to safety as this primary value, you're restricting innovation. You're restricting the number of at-bats that we have. I don't know. I don't want to get anybody in trouble for saying something that they don't want to say. So if you don't feel like answering this next question, which I'm still trying to figure out how to pose, that's okay. You say that Congress is the biggest factor upholding safety because they control the purse strings, I guess, for NASA, right? And that's the lever of control that they have. However, I have heard from various Washington familiar venture capitalists in particular, that a lot of congressional assistants who are giving advice to their as staffers, right? They're giving advice to their masters, don't understand space and don't value space. So I was wondering if you have an opinion about that. And so in that case, like, why are we letting them have that influence, right? If they de facto have it, I guess, because they control the purse strings, but maybe we could get a lever in there and do something about it.
Well, with rare exceptions, that's true. Congress doesn't care about space to first order. It basically, it just goes along with whatever the people who get themselves on the space committees want to do, and the people get themselves on the space committees maybe because they're interested in space, but generally because they have space in their district or state.
Yeah.
So they want to steer the money.
Yeah. So it's about employment, bragging rights,
keeping the cafeterias and parking lots full in Huntsville or at the Cape.
Okay.
So nobody, say there are rare exceptions. Dana Rohrabacher cared about space. Bob Walker cared about space. Newt Gingrich cared about space. But generally, people even on the space committees, they don't care that much about space except to the degree that it benefits their constituents.
And that's really unfortunate because space is a huge national security factor. The more eyes we have up there, the more ability to do something we have up there, the better. We have opponents who don't have this problem. They're doing, a little more aggressive, I guess, launches and that. China's certainly been to the moon more recently than we have, right?
And China doesn't mind dropping a rocket on
somebody's house. Yes. Yeah. Which again, we're not advocating that.
No,
but we are looking at look as from a purely rationalist point of view, right? They are willing to do the things to get the results, and safety is further down the list. This is very true. What would you say to somebody who just got hysterical about the idea of safety has to be that primacy, right? That high level, top level value. Is there any argument against that?
Yeah, the argument against that is if that's the highest value, you're not going to do much. When I say safe is not an option, that's literally true. There is no safe. There's no safe this side of the dirt. If you're living, you're risking.
Right. You could, old people fall out of bed and break their necks or bones and stuff and have serious injuries and die.
You're gambling with every decision you make in life is a gamble. You know, it could end badly. You don't know if your next breath you're accidentally pulling in some cyanide, right?
Mm-hmm. It just happens to be in the corner of the room over there.
Yeah, I mean, I'm just saying
Yeah.
the probability is low, but you know,
True.
yeah, you can be you're not safe in bed. I mean, you know, not an asteroid, but just even like a meteoroid could come in and hit you. I mean, people have been hit by
It's true.
by falling rocks.
Picture of a lady with a big bruise. Black and white. I remember that one.
So there is no safe.
Yeah.
It's just it's a matter of risk versus reward. That's you know, my recommendation to NASA is they come up with this arbitrary number, 1 in 270. Say, and it doesn't matter what the value of the mission is. It's the same number. You know, they could be doing like Columbia was doing kids science fair experiments, right? But they could be going off to divert an asteroid from destroying the planet. Okay? Seems like you should have a different risk level for that mission, right? You might send, maybe you only got a 1 in 10 chance of making it, so you send an armada of 20 of them.
Interesting.
But there's no correspondence between risk and reward.
Yeah.
When it comes
in this rating system. Yeah.
Safety is the highest priority. Period.
Okay. And unfortunately, the people who are insisting on that are the people who also value it the least. Safe space, you know, and results in space, which I might go after them with the, hey, do you realize how much this matters and how much it affects your daily life? Lots of people try to tell me spaces, why don't we deal with our problems, terrestrial problems first? Well, and I say, well, do you enjoy using the GPS on your phone? we need space for that. Oh, you know, you use that every day, do you? So,
well, you know, another example is ISS. You know, we were restricted to 6 crew on ISS because they had to have lifeboats. They had to have enough lifeboat for 6 people, and you had the 2 Soyuz that you could get 6 people back in, so that they could support a 7th crew. And if you did that, you'd double the productivity, because 5 out of the 6 guys, people, not guys and gals, are maintaining the station. There's really only about 1 person year per year
it's free to
research
something
being performed. So if you added another crew person, you would double the productivity. You'd get twice as much done. But they haven't done it. They can do it now because Dragon can
get up there in time.
Can go, and they can so they can handle 7 now. So they have a 7-person crew now. But for years, and you know, suppose you know they had come up with some, you know, working on some kind of drug, you know, that would save thousands of lives per year. That they came up with something to do in free fall that but they'd be very slow to do it because they were so unproductive, because they only have 1 person doing research.
Yeah.
So how many thousands of lives potentially did it cost us to worry about that one extra person that might get left behind if there's a problem on the station? You know, why? You know, the captain goes down with the ship, right? So why can't we have that attitude towards ISS?
Okay. I can imagine there are people who are going to freak out in response to this kind of talk, right? You know, like, we should be valuing all human life, et cetera, et cetera. It's just, I guess the argument on the other side is, look, what do you want to get out of it? And then looking at examples like we've brought up, you know, that you've brought up of other situations where human lives are not casually thrown away, but are used much more riskily, right? in order to get the objective of passing the sound barrier correctly in a vehicle that will continue to do it over and over again, right? Actually getting something that we use. I know, I think it was Marco Cross who I had on as a guest previously. We're talking about equipment manufacturers, and there's an issue right now about companies having flight heritage. If you don't have flight heritage, you're kind of, you know, stalled, right? And you're creeping up through the TRL levels, and then you kind of get roadblocked there. How do we give equipment manufacturers more of a chance to experiment and get their stuff included on flights so that they can get that flight heritage, at least have that check mark?
Well, it's getting a lot easier, because
Yeah.
it's getting a lot cheaper.
Okay.
I work with a company in Pennsylvania that
Mhm.
they build CubeSats.
Mhm.
And one of the things we do is we offer, hey, they don't worry much. They don't space rate their stuff. They don't care because
Mm.
it's so cheap to build the stuff,
Mhm.
and it gets obsolete pretty quickly. So they can offer, say, hey, you got an instrument you want to fly? We'll do it, for a reasonable amount of money.
Mhm. And
So
then it gets on a ride share and up
and
it
it gets
goes.
on a ride share, and it's so, and that's gonna happen even more when Starship is flying, when things can start to get really cheap.
Hmm. Hmm. There could be an impact on the clutter in space from that, though, with a whole bunch more stuff going
That's
up there. So you
Yeah,
need to
that's
design,
another issue. Yeah.
hopefully design for recovery. Uh,
Well,
somewhere we need a space forge, or we need something to recycle material up there. That's one of those basic building blocks for orbital construction that I'm very keen on. We need an orbital construction platform and a space forge, and a sort of
Yeah.
cycle of gathering resources and bringing them there, and then having a platform to hang things off of and build something. And then maybe we'll actually get a space economy here. But before we do that, I think we do need to go through a clutter phase of more stuff, right? Being tested.
Unfortunately.
Yeah.
And these large constellations are going to be a potential problem.
Yeah.
We,
And
we're
we'll come
risking.
back to that in our third topic. So folks keep listening, because there's something I had a talk with Ran here, I think a week ago, and it was really informative. And that's why we're jumping on to talk about these topics, because he brought up a couple things that I really hadn't thought of. And the next one here, after safe is not an option, the book is building codes for orbital facilities. So cislunar, beyond Earth orbit, and Earth orbit. And I'm a compliance guy. I'm an operations management guy. I'm a logistics and supply chain guy. I'm very interested in the order in which things are done, right? And then what standards are we holding them to, and who came up with this stuff? Because there's also a big part of me that's, anytime somebody asserts something, the very first thing I'm going to think is, well, what's your proof? Right? Who said that? Where'd that come from? Right? And so having somebody just give a number like NASA did there, or give a statement or a standard, I'm going to question it and go, well, where did that come from? Right? And then if they have a good reasoning behind it, then I'll accept it and work with it. But sometimes you just have to take those constraints and work within them. So I had not thought of building codes for these orbital facilities before you brought the topic up, and it kind of appalled me. It's like, oh my goodness, there's all these other rules and regulations, right? I guess the reason is we just haven't had operators doing anything like this.
Well, nobody's built a space station except governments
Mm-hmm.
to date. Right.
So what codes exist? Are there any?
Not really.
Yeah.
I mean, like the other day, the ASAP, Aerospace Safety Advisory Panel,
Mm-hmm.
the other month, sometime this year, said something about these commercial LEO destinations, CLDs. That's what they're calling these new space stations, these commercial space stations, CLDs, a TLA.
You gotta have an acronym for everything.
Got to have the TLA there, 3-letter acronym, which is recursive, obviously.
Yeah.
But they said, we don't know how we're going to human rate these things. And I said, what does that even mean? I mean, one of the points I make in the book is that human rating is a phrase that we should purge from our vocabulary.
Yeah.
It's because very few people even know what it means, but they throw it around as though they think, because they make it think, they think it makes them sound smart and like they know what they're talking about. Oh, it has to be human rated. But shuttle was never human rated. People don't realize that, but it wasn't, because it did not have 0-0 abort capability. So, and that's
so let's define those terms then.
Yeah. Well, so what I say, again, let's not talk about human rated, just talk about what's the risk, what's the reward, what's the probability of loss of crew. There is no right number, but you have to decide. NASA said, well, there's a right number. We came up with 2.1 and 2.7. No, there is no, it depends on what you're doing, right? So same thing with human rating. No, you don't human rate a space station. It's, water is potable, right? We don't say this water is human rated. No, it's potable. You can drink it. Okay. So this facility is habitable. You can live in it. Okay. What are the risks of living in it? Well, you have to analyze that. What can go wrong?
Yeah.
But it's designed for people to live in. It's got air, it's got thermal control, it's got, it's habitable. And that's all we really need.
Mm-hmm.
So the issue is that about a year and a half ago, NASA has been gave money to several companies, Axiom and Orbital Reef and others too. It was kind of based on the commercial crew model. We'll give you money to meet milestones, and then you'll satisfy requirements, and then we'll use your space station. But that commercial crew is actually kind of a bad precedent, and I don't think we want to carry it forward. Where NASA actually certified
Oh
the
yeah,
vehicle.
right.
Okay, so because now NASA is talking about certifying these space stations, and we don't want that.
Mm-hmm.
And there are reasons. There are at least 3 reasons why that's a bad idea. And one is they have no statutory authority to do it.
Mm-hmm.
2, it implies that if NASA hasn't certified your space station, that your space station's not safe, right? So it puts the people who aren't, working with NASA, they're just developing commercial space stations for commercial purposes, puts them at a competitive disadvantage. And the third is that, getting back to our precious astronauts, it implies that somehow NASA astronauts have to be safer than just people going up for fun or to do research on their own. That has nothing to do with NASA.
Okay.
It's just bad optics.
Yeah. Yeah, and I mean, it seems kind of silly if you were to go to the point of, say, the station has artificial gravity to make it human rated. They're telling you need this kind of mattress, right?
Yeah.
Where does it end to make it human rated? Around those corners so that nobody gets bumped, right? Childproof it. So yeah, it seems a bit silly after a point. Okay, so who would ultimately have a responsibility for coming up with a building code? I mean, we obviously need the operators in there. Governments are responsible for the activities of their citizens, so they probably should be involved in some way.
Well, NIST does that kind of thing.
Yeah.
Right.
Mm-hmm.
So it should be done the way it's been done in other industries. You have ANSI, and you have ASTM, and you have NIST, and industry should be working with those entities.
Okay.
We have the Space Infrastructure Foundation, Fred Slane. I don't know if you know Fred, but he's in Colorado Springs.
Okay.
He's the head of that, and he's also now the ANSI representative for space. So you get those people together, and also in combination. I don't know if you're familiar with the cislunar ecosystem task force, which AIAA just started this year, which is trying to kind of pull all this stuff together and integrate it to make, coming up with standards is one of those things. So, but it should be industry led, and it can take input from NASA, and NASA probably they've learned some stuff from ISS, sure. So we'll listen to them, but it should really be an industry led effort. Working with NIST and working with the Department of Commerce.
Okay. How long does that take? And does it slow down companies getting facilities into orbit?
Potentially. I mean, that's one of the other concern of NASA certifying. It slowed us down, getting commercial crew going.
Right.
And there's certainly a legitimate concern that it's going to slow down. If NASA is doing certification, it's going to slow that down. So again, I guess the question is, what risk versus reward? What are we willing to do in the near term? How much risk are we willing to take in the near term till these standards get developed? And it's an ongoing process, right? There's, it's even on the terrestrial standard, it's a never ending thing. They come up with new codes all the time.
Yeah.
right? As technology evolves.
Yeah, we get new, yeah, in building, we get new materials. We discover stuff that we thought in 1950 was really good for insulating a house. It doesn't quite work, or it makes it moldy, or
Right.
the water
Yeah,
gets
or
in somehow after a while.
yeah, or we don't have to solder copper anymore. Now we
Right,
have other
right.
means of running plumbing,
Hmm.
other ways of doing electrical, using more modern technology. So whatever you come up with is going to evolve, but you come up with some basic things that says,
Yeah.
here's what kind of margins you should have, structural margin, as a function of what your atmospheric pressure is. You might have standards for, well, you ought to have a minimum of 8 psi or 10,000 feet equivalent or something.
Hmm.
You ought to have minimum oxygen partial pressure, for fire safety, those kinds of things.
Yeah, I would hope there was some pressure vessel knowledge that could be transformed over to this. You don't have pressure pushing in the way that we do in atmosphere, but I imagine there's certainly pressure pushing out, and the metal has to be
certainly
strong enough.
positive pressure is a lot easier than as we saw with that recent incident with the Titanic.
Yeah, the submarine, right?
Yeah, take negative pressure is tough to deal
Mm-hmm.
with.
Mm-hmm.
It's pressure vessels are easy if it's a balloon.
Yeah. So once again, it goes back to risk tolerance and what we're willing to accept to get to where we want to go. It's an ongoing thing. So the work is never going to be done, but we have to come up with something. It should involve industry stakeholders. Just from my own experience, I'm feeling like the 4 or 5 or 10 people in the room, I wouldn't make it much more than that, really have got to be the right people for the first draft. Otherwise, it's going to take forever, right? If we get people who are a little too nitpicky or just obstinate because they enjoy being a force in somebody else's way to appease their own ego, gosh, we would never see anything like that, would we? It would really slow the process down. So if you could get some people who know each other, or at least respect each other, to work together on this thing, they might be able to get something together in 6 months. I would hope. I wonder if there's a potential of using AI to go through existing codes and pull data or talking points basically that could be relevant, right? And then have a faster starting point from that.
Maybe
Something that strikes me right now. Yeah.
as long as it doesn't hallucinate them.
Right. Yeah, exactly. I mean, there's got to be a lot of double checking to make sure. Okay. So is this happening already? There's some discussion, like you said, with the AIAA, in for at least this lunar space. What about building code for everywhere else?
Well, I think there's be some basic things that are applicable universally, literally, universally.
Mm-hmm.
It's in Leo, you don't have to worry as much about radiation.
Yeah.
Particularly if you're equatorial, which we'll talk about.
Mm-hmm.
But so it's things are less stringent for Leo. Once you get out beyond the belts and Allen belts, then you have to start worrying more about the radiation concern. But other than that, I don't think things change a heck of a lot.
Okay.
And of course, it'll be different if you have artificial gravity or not.
Yeah. I guess we should talk to Rhonda Stevenson, somebody like above space, somebody who's actually manufacturing these things, to see. That would be a good question. Where are we starting
or
on this? Yeah. When this episode comes out, I think I'll tag her, see what she has to say, if she has time to look. Okay. We've got this very interesting thing coming up. We've all heard about space junk and space situational awareness. The first book that I put out is on space situational awareness. I have a business of space book coming and a space law book coming after that. And I could probably do 2 books on each of those from the interviews that we've done here and everything that I've learned by talking to folks like yourself, right, who have been there and done the job. And I was sad when Celestrak lost their funding and you couldn't go to the site anymore and see all the orbital pathing, but there's been something I just found out about the last week. I think it's spaceaware.io, which basically looks like a Celestrak clone. It has the same animation. And I was like, yes. I was able to share that with some people locally who were interested in what are these dots going across the sky, and half of them knew it was Starlink, and half of them probably don't know that NASA's still operating, right? And so to share that with them, that space aware thing, I'll put it in the notes, was really a pleasure. And so you get to see how many satellites are actually up there, and of course it's not to scale. A dot up there is not the size of the satellite. It would be much tinier, but we do have more launches, a lot more small sats going up there, and there's going to be an area that you've identified, and I'm sure you're not, you're not going to claim to be the only person, but you are highlighting discussion about this, and I was like, I really haven't thought about this. I've thought about the space situational awareness problem, right? And so we're talking about you're launching a lot more satellites. We have to identify, track, and predict the orbit of all these things to avoid something else crashing into them, right? Or are they crashing into something else? And so there's one unique orbit that is going to become super important, and that's equatorial low Earth orbit, right around the orbit. And this is what you've identified and brought up in our chat last week. And so tell us a little bit about why this orbit is unique, why it's such a big deal, and what, in terms of clutter, is going to happen in this relatively narrow band of space around the Earth.
Well, okay, it's a unique orbit, as you said. It's the only 0-degree inclination orbit. Every other inclination has an infinite number of orbits, because you can have any number of orbit planes with different ascending nodes, the place where the orbit crosses the equator. But equatorial doesn't cross the equator; it just lives on the equator. So there's only one orbit plane that's got the 0-degree inclination. So what does that mean? It means there are no launch windows to get into it. Anytime you launch, you're in that orbit. If you want to do a single orbit rendezvous, you get an opportunity to do that every hour and a half. It's very nice. It's also the lowest radiation environment, because it doesn't go through the South Atlantic anomaly. It minimizes the risk of something falling out of it onto somebody on the planet, because it doesn't cover much of it. It only goes around the equator. The only thing it could fall on is somebody who lives on the equator. But it's nice. It would be nice to get as much as possible, into a single orbit plane, because now you don't have all these different planes, different things coming in at different velocities from all kinds of different angles. Everything is just very low relative velocity. It's very easy to manage traffic if it's in a single plane. Now, of course, the issue is a lot of things can't be in equatorial. Can't do that. You can't do your job as for Earth observation. If you're at the equator, all you're going to see is the equator. You can't do communications. You can't do the kinds of things that Starlink is doing. So there's always going to be a need to be in other inclinations. But anything that doesn't need to be in other inclinations ought to be in that orbit. It should be, I call it Earth's natural harbor. Everything going to or from space should pass through that orbit plane. All the other advantages, you get maximum advantage of Earth rotation. So it's a place you can get the most payload to with any given rocket. In fact, if you ever do want to do single stage to orbit, that's where you want to do it, because the big problem with single stage to orbit is that its off nominal performance just sucks. If you need to go to a higher altitude or a higher inclination, your payload drops off precipitously, because you have so much more mass. You have to move the whole rocket has to go to that higher inclination or altitude. So you really want to minimize the delta V you need to get to orbit, and equatorial does that.
So put it up there first, and then get a momentous orbit mover or something to fly over and push you up higher. Okay.
Yeah, and that's the objective. Oh well, it costs. It's so expensive to do a plane change in LEO, in terms of delta V? Well, the answer is yeah, it is. But if you got a Starship situation where you have basically, we're going to get out of this situation where launch is, oh, you go into this orbit plane with this rocket, you deliver the payload, and you have a launch window, and maybe you have to worry about weather. Oh, you don't have to worry about weather at the equator either, by the way. No hurricanes there, because they can't cross it. They don't even come very near it. But the traditional model for the last 60 years has been, you have a payload that's going to go to a certain location, you put it on a rocket, and it goes there. Okay, so for example, we send a cargo to ISS on a Falcon 9, costs $60 million for 20 tons, something like that, right? So somebody would say, well, okay, so if I want to get to ISS, I don't want to go to the equator, because then I have to do a 52-degree plane change to get to ISS, and that, how much that going to cost? It's almost as much delta V as it is to get to orbit, right? Okay, but suppose I've got propellant on orbit for $20 a pound. Okay, so you can run numbers and say, okay, with a cryo stage, I can do that 52-degree plane change with $5 million worth of propellant, which is a hell of a lot cheaper than buying a Falcon launch.
Yeah. So our commodities market opens up. Guys like Daniel Faber are happy. The one's putting the gas stations into space, and there's a very clear financial application, right, to doing this. Okay.
Yeah.
Given,
sorry about the noise here. Phone's ringing.
Okay.
You don't hear 'em?
Zoom did a good job of screening that out. Yeah.
Oh,
So I've had a lot of discussion about space tracking and infrastructure on this show with folks like Maury Baja and T.S. Kelso, other guys who have PhDs, right, and have been highly involved in this stuff. The state of that technology is kind of old, duct taped together. It could use a lot of improvement. And also, we don't put transponders on things the way we do with aircraft, so it's hard to tell who's what where. And now we're talking about throwing a heck of a lot more items into one orbit. And like you say, the plane is the same. So they're all, in terms of three-dimensional cannonballs or whatever, they're moving fine in that one direction, but there's two other things that they're doing. What infrastructure changes would you think that would be needed in order to handle this increase in capacity that we need?
Well, as I was saying, we're going to get out of this model where you launch to a particular a rocket to a particular location. Instead, think of it, if you have starships, maybe, and the disadvantage of equatorial, which I should mention, it's great for all the reasons I just said. The big disadvantage is you have to launch from the equator, and we don't have any equatorial spaceports.
Oh.
Okay, so but people like Tom Murata, or he wants to build floating platforms. Okay, and Elon's talked about that for Starship as well, partly because he wants them outside cities so he can do point to point, right? So if you've got a floating platform, you can put it at the equator. In fact, you can have another one downrange where you could land your booster and get even more payload. Probably 10-20% increase in payload if you don't have to fly back or don't have to boost back. And so you can land on the platform downrange, it can refuel there, and it can self-ferry back to the other one, right? And you might even have a bunch of them. You can just kind of hop around the entire equator. But basically, so we're going from a model where we have a specific rocket, payload on a specific rocket to a specific place, to just basically just a mass pipeline, daily scheduled flights into orbit. So it's like the transcontinental railroad of space. So now you're not going to say, oh, I'm going to build this satellite and put it on this rocket. You're going to say, I'm going to put up a bunch. I'm going to have propellant up there. I'm going to have building materials up there. I'm going to have assembly facilities up there. So everything is going to want to be in that orbit. You're going to have resorts, space resorts, for people who don't care whether they see the planet or not, but they're just They're just up there doing stuff in space. Be a way station. Sorry, I got a cat going crazy here. So it might be a place where you stay, before you get your shuttle to the moon or somewhere else. But again, I say everything would be passing through that orbit, either departing or coming back from cislunar space and beyond. I
was surprised there haven't been any equatorial spaceports. I know there's launch sites like French Equatorial Africa.
Well,
they occasionally do it, but
Alcantara is close to the equator.
I'm like, have they avoided putting money into building it out because it's not our country, it's not local?
The U.S. isn't going to invest in a Brazilian spaceport. And Peru is not far from the equator. That's why they chose it, because they saw the primary market as geo, and you don't have to do a plane change. If you're equatorial. I mean, that's the other thing. It's very accessible to geo because you don't have to do any plane change. You get to geo, you just have to change your altitude.
Okay.
But I just think of it as, like I say, it's Earth's natural harbor. Everything's going to be happening. That's where all the action's going to be.
Yeah.
Anything that needs to be in a different inclination, you'll put it there.
Do you think it's likely somebody going up to a space resort will be able to look out a window and see an orbital construction facility, at least if they flew by it?
Well, you're not going to fly by because everything's going around like beads on a string.
So your relative motion keeps you the same distance away. Okay.
Yeah, but which is a good thing.
Yeah.
Right.
It helps avoid those collisions we talked about. Yeah.
But things will want to be close together. I mean, it might be that people who are working on that those assembly hangars don't live there. So they'll just do a little orbit phase to get back to their room at night. So they could stay at the same hotel as the partiers and the people who are on their way somewhere else. So it would be could be close vision.
Bring back today's video log of what happened and show it there.
And there'd be telescopes, so
that's true.
No atmosphere to look through. So even if it's 50 clicks away, you could probably have a pretty good view of it.
Okay. That's kind of neat. Yeah. Or they could take that image and project it onto a big screen so that people could watch it without peering through something. I like it. It's going somewhere. Is there a maximum number of resident space objects that could fit into this orbit?
Probably, but
it's just
I'm
physically
sure it's pretty big.
Yeah, I would imagine.
And it depends on the size too.
Yeah,
right?
Yeah.
What about a good place to assemble solar power satellites? Right.
Okay. Beaming that back to Earth, or using it up there. Okay. What about radio spectrum? Would that fill up even faster than any sort of physical constraint that we have? Do we have enough bandwidth to communicate?
I think people would be using lasers.
Okay, and just signaling ... dash whatever would be interesting.
Well, it'd be digital.
Yeah. Okay. Will this have any impact on launch? Having all those that clutter up there? Would that slow things down, or you'd have to wait for a window, or?
Are you talking about equatorial?
Yeah.
No.
Okay.
No.
It's always going to be open.
It's all like I say, there is no launch window to get into that orbit.
Yeah.
It's only if you want to be in a certain place in the orbit. If you want to rendezvous with something, then you have to wait at most an hour and a half.
Yeah. Oh, it's not long.
Yeah. Because everything that's about the orbital period, right? So every time something comes around like that, you can have a shot at rendezvousing with it.
All right. Well, Rand, I appreciate you doing this. It's been a very interesting conversation. You brought up a few topics that I really hadn't explored in my head or even thought of at all in the building codes case. That was very interesting. We'll all check out the book. It's on Amazon. I'll link to it in the description below. Who do you want to talk to? Who do you want to meet?
Hey, had thought about. Never.
Ah, okay.
Much thought. I've met a lot of people. You know,
Yeah.
I know a lot.
Well,
of
you
people,
reached out to
so,
me. Yeah.
Yeah. So, gee, like, nothing jumps to mind.
Okay.
Uh,
Are there any areas in space industry discussions that you want to have a voice in?
Well, I want to make something happen with this building code thing.
Mm-hmm.
That's
Okay.
what I've been trying to do and I've been talking to Axiom and Orbital
Mm-hmm.
and Rhonda and other people, trying to coalesce some kind of industry organization, something equivalent to the Commercial Spaceflight Federation. But CSF can't really do this because I don't think that Karina has the bandwidth or the resources to deal with it, and she would have to get consensus from everybody. So it really
That's the hard part.
might need a new thing like that, except I would call it something like the Commercial Orbital Federation or Commercial Orbital Facility cost. And we would have something like the ComStack. We'd have the Commercial Orbital Advisory Committee.
Right. Okay. If somebody does want to reach out to you, what's the best way for them to connect with you? Email. Okay.
Simberg. Simberg at interglobal.org.
Great. All right, Rand. Is there anything we didn't discuss that you wanted to cover, or we covered what?
Probably.
Okay. All
But
right.
I
Well,
can't think of it right now.
yeah.
So
But you can always come back and have another discussion. Thanks for doing this.
it's a good time.
All right, so really interesting discussion there on building codes for orbital, cislunar, VEO facilities, the uniqueness and benefits of equatorial LEO, and Rand's book, Safe is Not an Option. I'm going to link to that in the description below on Amazon if you want to go check that out. So Rand, thanks for doing this. It was really educational and I had fun. So if you are a space or defense business owner and you've got a to-do list as long as your arm and you're feeling like you just can't get any help with it and all your employees are full, come and talk to us at Cold Star Tech. There'll be a link to that in the description as well. Book a time to talk with me and tell me about the kinds of problems that you're experiencing. I want to hear about them and I want to help you solve them. Not just do an analysis and give you a report and run off, right? I'm talking about getting in the trenches and actually doing the work, which is what we do, to help you and your company be better. Thanks for listening.